All right, hello everyone. My name is Jonathan LeBlanc, and I lead the developer evangelism efforts for North America at PayPal. A lot of the stuff that we've gone through recently within PayPal, within other companies that I've worked with, have been complete API overhauls, API development decisions. I've worked with everything from APIs that are SOAP-based, the early days of PayPal, until our recent revisions of RESTful APIs. So some really painful stuff that we've had to put developers through. And I worked with others that have been designed specifically for security mechanisms, building out a perfect system for the company itself, but really not taking into account the efficiency of developers, taking into account the speed at which they can develop, the ability for them to really create something easily on top of your products. And this is specifically what we're going to be talking about today, is taking a look at API architecture and the different trade-offs that you have to go through in order to really build out a complete system for developers, something that's easy for them. So as we're looking at the exploration of API design, as we're looking into the different types of the ways that you can construct something like this, you can basically take a look at two models. Now, these are the typical models that you would see within API design. Basically, everything that you might want to build out comes from these two models. First, you can start with a blank slate. Now, this is a very typically creative mechanism for building out an API infrastructure. You start with nothing, and you're building out basically every mechanism in order to support the developer community. And a good way of thinking about this is, how many of you here have worked with PayPal APIs before? Okay, a number of you. So the one thing that PayPal's old APIs used to have was a whole slew of error codes. Now, these are custom error codes that weren't anything HTTP response specific. They were customized for their particular needs. And each one had to have a lookup mechanism in order to see exactly what the error was. Now, these are all customized builds and things that were specific for what they wanted, but really didn't fit with the developer methodology, because nowadays you want something that's standardized, something that you can take with multiple different APIs, mash together, and build a single error response structure. This is what you want. But this is a very creative solution to start from the ground up, and you see this with a lot of solutions out there. The other mechanism, and one that's very fit for RESTful-based services, and really the norm nowadays, is the issue of constraints. So as you're going through a constraint-type architecture, you're basically taking the web as it is, you're taking HTTP status, you're taking the request-response structures that are already out there, basically the build of the internet as the developers know it already, and you're imposing constraints upon that to make it easier for them to work with. A structured way for them to build upon your products, but you're building upon the base level mechanisms that everyone already understands as they're developing on the web anyways. So this is the type of response structure that we're really looking at here, because it is a beautiful mechanism for working with, because you're building off fundamentals that are standard. And when you're building out developer methodologies, this is what you need. So when we're really talking about these mechanisms, what we're really going into here is that APIs really do need to be developed for developers. I've gone through too many painful integrations, integrating thousands of different developers for multiple different companies, to really go through another painful integrations. Something that's more secure, more reliable on the server integration, but painful for the developer community. That's the last thing you want. Now, the one thing you have to remember is that you're not building APIs for a perfect system for the server. You're trying to build out the perfect system for your developers. That's what it's all about. And when it comes to the RESTful-based API architecture, it's all about trade-offs. There is no silver bullet. You're not going to have a perfect mechanism that's going to work in every instance. Essentially, you're dealing with constructs such as scalability, reliability, developer ease of use. And all of these mechanisms have just sliders. So as you're building out an API infrastructure on top of these mechanisms, you're just moving the slider back and forth. You want more reliability on one side, well, you're going to increase the latency on the developer side. So if you want a more scalable architecture by layering out your architecture on your server side, then you're going to impose a perceived latency on the developer. Again, just trade-offs as you're going through. So we've gone through a lot of this at PayPal in the rebuilding efforts, where we take these old SOAP name value pair APIs and migrated them away into the new RESTful-based services. This is what we launched in March, and we learned a lot from it. Basically, the architects, the people like myself who engage with the developer community that have been doing it for their entire careers and are very, very vocal about the pain points of the old systems. All of us, we're the people that built out these systems. The people that built the new API infrastructure, and there were a lot of things that we learned. A lot of things that we learned as we were building out these systems in multiple different companies. So there's trade-offs. There's definitely the things that you should be working with as you're going through and building out an API architecture. And when you're focusing on the developer community and building out a structure for them that makes sense, that makes it easy to build, basically the people that are your customers, the people that are bringing in customers. So these are the people that you should be focusing on. So one of the big issues that we ran into on a trade-off architecture within RESTful services is the issue of perceived latency. Now, if you've used social-based integrations before, you'll know that if you have, let's say, 100, 200 millisecond delay, you'll see some user drop-off as you're going through, as they perceive a latency and a slowing effect as you're going along. But it's not really conceived as a huge detriment for many companies. In the payment architecture, this became a huge detriment for us because latency directly related back to monetary loss. As you had an increase of 100 milliseconds of latency based on your layering architecture, you would see direct revenue drop in the companies that were building on your APIs. And in any social-based integration, if you're working with these types of systems, you have to be aware of latency when you're working with the developer community. Your users are going to come in and you're going to see user drop-off. And that's the exact thing that you don't want. You want to see a hockey stick type of growth. And lowering latency is one of the reasons to do it. So when we're looking at a RESTful-based architecture, there's definitely a couple of trade-offs that we're working with. Again, sliders back and forth. You have to be aware of things that you're going to be working with. So one of the typical reasons for perceived latency within a RESTful-based architecture is the aspect of system layering. Now, system layering is going to give you a way of separating out concerns. Your concern areas might be things like classic or legacy systems. They might be things like different types of business models built into your API architecture. It's really a way for you of separating out the overall constraints within your architecture, right? It makes sense. Just like you would have a class-based structure, you would separate it out into specific modules that would have their own functionality. You would have the same thing with an API architecture. But when you start to really separate things out and build out these individual concerns, the problem is that within RESTful APIs, the specific layers that you're going through only really have knowledge of the next hop that they're going through, the next point that they need to jump through. So if you're separating out, let's say, in our case, it was classic APIs versus our new RESTful APIs, then that makes sense. Do a complete separation because they don't affect each other. But if we start breaking down the RESTful APIs and breaking them down into individual sections and having multiple hops that you have to jump through, the latency increases, even though it makes it much easier and much more scalable and reliable for us to build out this way. Your end users, your developers, are going to see the pain points. And the way to get around this is typically for building in caching mechanisms into these layering types of effects, where you would have cached results for any static data that's coming through. So in this way, you can return content quite faster, as most of us know. The biggest problem with the caching-based mechanism here is the issue of reliability on the developer side. So with system layering, you get the scalability of the server side or the API implementer, but a higher latency on the developer side. With caching, you get much better latency, much lowered latency, but your reliability drops because of the potential for stale results, for stale results cassettes coming back. So again, you just have to figure out exactly what fits your developer methodology. You have to have a layered type system because it's going to give you a much better way to scale your architecture. But at the same time, you don't want to overlayer, and overcache, because then you're going to have a whole other set of effects. So as we're breaking into the layering type of effect, really there's a couple of reasons why we would build out this system, why it makes sense to build on top of a layered type of system. First and foremost, it encapsulates these legacy systems. In our case, the classic APIs. It makes sense with a lot of companies that have been out there for a while. You don't want your classic systems or your legacy systems impacting your new systems. So in this way, what you can do is completely separate out the concerns so you can build them up individually. As we're not putting in any efforts into our classic systems, we don't want the new updates to the RESTful APIs impacting those results. We want them to be stable. Then you can oversimplify your components, making it much easier to do hop to hop. And as you simplify the components, it becomes a much more reliable system. As you're going through, you can also build in mechanisms for bottlenecks. So let's say we have a payment architecture where we're pushing a lot of people through to a specific endpoint, making a payment, let's say. That's a potential bottleneck, and as we start to layer our systems, we can have load balancers in between those layerings so that they can funnel the traffic to applicable servers and handle that type of load in a much more efficient way. But these load balancing systems will give you those efforts within there, and that's exactly why you want to have a layered type of system. And then obviously the systems can themselves evolve independently. As you layer each section, they're completely separate from each individual concern, with the exception of the previous hop. So as you're building out these structures, you can completely build on top of a legacy system. You can build on top of a new system. It doesn't really matter because they don't impact each other, because you've layered the type of constraints in there. And really what it comes down to is just a complete separation of concerns. Any concern area in your developer methodology should be separated. It should be separated into many logical steps, because this is just how things work. When you're building on a scalable architecture that's performant for developers, you want the ability to easily diagnose problems on the server and integrate new feature sets, and this is the way to do it. Now, when we're dealing with these separations of concerns, I mentioned that you have a potential for latency issues. Now, as you impose those caching systems in place, the reason why you don't want to really have too much in there is because you have a lot of potential stale data. But one of the other issues within a RESTful-based architecture that you're going to run into is that of the stateless system. Within the architecture, basically what it states is that you're going to manipulate these result sets by sending in a complete payload through that any of these hops that you're going through within a layered-based architecture can understand and run. Essentially, the payload that you're sending through to the server has to be descriptive enough to be able to run the entire request without anything like a stored procedure on the server side in order to augment that to make the request. Basically, the systems are dumb of the overall architecture coming through, of the payload coming through. They just simply run the request. It makes it really easy for each individual hop to run everything at any given interval, which is what you essentially want. But you run into the problem of data duplication. As you're sending in these large payloads coming through, you might send in your first request A and B, whatever they might be, whatever objects they might be. You might send A and C as your next request. Now, obviously, a good way of scaling this back and making a smaller payload is to, let's say, dump A into a potential store procedure to make it easier to run. But within a stateless-based architecture, you're not going to have that. So you want to, so the potential for data duplication is there. You're going to have much larger payloads. And then, of course, the caching-based mechanism is going to give you that basically latency reduction, which is what you're going to want to build out a developer-efficient API structure. As you're building out your caching mechanisms in each hop as they're going through, sending back any potential data, you want to make sure to scale that caching mechanism so it doesn't give you back stale data or has a much lower likelihood of sending back stale data where it counts. All right, so one of the other big concerns that within any sort of API architecture is within this constraint type of methodology that we've been talking about within RESTful-based services, it's the aspect of using HTTP properly. Now, all of you have probably gone to a lot of booths and talked to a lot of companies, and I've had a lot of them myself that have said, oh yeah, we support REST completely. We support GET and POST. I hear that all the time because it's basically a misunderstanding of how the HTTP architecture works. While supporting HTTP concepts properly is a portion of what REST is, it's just the fundamental base architecture for everything you're building on top of, everything that you're imposing your constraints on. And when you're really looking at the potential trade-off here, you get your donut, you get your apple. What are you trading off really when you're using HTTP properly, as opposed to a system where you would have, let's say, your custom-based architecture being built out, where you're custom-based your error codes? Well, for myself, I don't see a trade-off here, because any single implementation that you would want as a developer methodology in place there as a potential trade-off, you can put inside of the standard response structure that HTTP already supports. Standard response codes coming back with descriptive messaging can handle any sort of error code that's coming back and make it much easier and much more efficient for the developers building out the products. So when we're really talking about that, it's all about supporting proper request and response structures. This is what developers are used to building on top of. This is what I'm used to building on top of. And as you have multiple APIs that are mashed up together, and let's face it, when you're building out an API architecture or API integration into an application, that's what you're going to get. You're going to have multiple APIs coming back and forth. So supporting things like standard HTTP methodology, get, put, post, delete, as well as the entire HTTP structures, you will want to support this because it's going to make developers' lives much more efficient. And you know what? All of these response structures actually have a specific concern area. They actually have a specific reason that they exist. You can have a standardized endpoint. Let's say it's something like api.paypal.com or whatever it is, /payment. That's your endpoint. Now, using proper request methodologies, you can actually have completely different effects within the API structure. You push through a GET request to that same endpoint, that can mean that you're looking up payment information. You put through a put and post request, that might mean you're creating or modifying a payment that's already out there. You send through a delete, that might mean that you're voiding or refunding a payment. They all have specific reasons to be there, and unfortunately, within a lot of APIs that are built out right now, it becomes interchangeable. The same companies that say they support GET and POST as standard methodologies, if you notice, sometimes they'll actually support both interchangeably. So you can send through a GET or a POST request, and it means the same thing to them, which isn't how it should be. And then, of course, the proper status set and error codes coming back. The last thing that you're going to want is to build out a structure where people have to actually go to a website to look up error codes. Why would you ever do that to a developer community where the onus is on the developer to really build out a proper response structure based on some custom error codes? In this way, you can't build out a very good support error system in order to handle multiple APIs. But with proper status codes being returned back, 300 range, 400 range, what have you, you can support all that and support multiple APIs at the same time. And then another big concern area, and this is one that PayPal did pretty badly in their classic APIs, which led to this big revision. Things like this. This is bad to send back to a developer community. Sending back an error with error 10008 is silly. Come on, because essentially what you have here is that the developers themselves are going to have to go and look up this specific error code, or parse out this response and build up an error code lookup, because it makes no sense. Instead, do something like this. This is a proper response structure that you get back. You have your HTTP error code response. You have your proper content length and your descriptive messaging that tells you exactly what's going on. This type of methodology is what you want to build out, especially when you have an efficient developer offering. All right. Here's one that I really, really love inside of API requests, and it's inside of API structures that are built out. the ability to build in some sort of automation mechanism. And within the RESTful-based architecture, that's through HATEOAS types of links coming through. It's another hypermedia constraints portion of the RESTful specification that makes it quite nice to actually build in these automation structures that make your development lifecycle very scalable. So as you're building out developer products, and the developer products themselves are changing constantly, new versions are released, this type of system can actually be imposed inside of a developer product to make it easy to develop and not break. I don't know about you guys, but I've worked on plenty of APIs that push out new revisions without really notifying the developer community and completely break an API infrastructure or your app integration every time. Happens all the time, especially with versioning. Now, one of the things that you're going to run into with a type of an automation request or automation structure with HATEOAS is something like payload size. So obviously, the way that it works is when you send your request structure through, an application really only has knowledge of that first hop into the system. What's going to be returned back to you is a link structure containing all the potential next steps that they could take. Obviously, that the application really doesn't understand where the entire API architecture that they're going to be dealing with, but the response structure that comes back has all that information. So building this allows your developers to build in an automation type of effect. Now, what you're also dealing with this type of system is the ability to reduce code length. So what you're going to get with a system that's a smarter system, that's a smarter build-out, is that the code length of developers will decrease. The efficiency will increase, the latency will decrease, because you're going to have smarter-based methods built in. And this is really what you're dealing with here. You're sending back a larger payload, but you're making it a lot easier for your developers to build in an automation type of effect. Now, there's a good way of looking at this. This is how I like to think of HATEOAS and the overall API structure that you're dealing with. This is the way that we normally consume APIs within a system that doesn't support this. The application in the middle has knowledge of any potential application state that they might want to reach out to. Makes sense. So in our world, it would be something like making a payment, making a refund, auth, capture, what have you. Has knowledge of everything that you might want to do, and you have to have a wrapper for each methodology call. But this type of structure makes it incredibly unwieldy. So what happens is, as versioning gets pushed, as new endpoints might get pushed, this type of system can't support this. This type of system can't support new updates, can't support changes in the architecture, because they have to be manually altered. But using this type of HATEOAS type of link structure, what comes back to you is the next hop. So let's say the application structure on the side there only has knowledge of, let's say, auth capture. They want to do auth capture for their app. And so authorizing funds for later capturing. So they have knowledge of the first entry point, which is authorization. That's all they have. That's all that's built into their structure. What comes back to them is a link structure saying, here are your next potential steps. You might want to capture. You might want to look up information about the authorization call. You might want to void that call. Then, let's say you capture those funds, making that next request through. Then they might say, here's looking up information about the payment. Here's how you make a refund, etc., etc. Within RESTful services, this is what it tends to look like. So in the payload that gets sent back to you in the response structure, you would have a series of link structures that come back containing all the information that you need in order to make the request. It has the relevance on what it might be, like looking up information on the self, or capturing the payment in auth capture, or avoiding the payment. And then the method, the HTTP request method that you're going to need in order to make the call. It just makes sense for automation. It makes your life a lot easier when APIs support this type of methodology, because it makes your application architecture scalable and reliable. And the overall latency can be offset with caching-based mechanisms if you do something like this. Now, one that I run into all the time, I mean, I've worked with auth-based systems for a long, long time through PayPal, X-Commerce, back in my Yahoo days in CBS. Now, developed with auth, for for many years in many complexities and many variations of complexities. And when I first started, basic auth was very, very prevalent. People would be sending through their usernames, their passwords as a standard for applications, and then they would just store the structures. But a lot has come from that. So back in early development days, when OAuth 1 first came out, amazingly secure system that was great for the server-side implementation, very secure, but it was a pain in the butt for developers to work on top of. OAuth 2, OpenID Connect came along, made it much easier for developers to build, but the security, all the security mechanisms weren't there. So the trade-off that you always had within auth-based structures, basic auth, XAuth, BBauth, OAuth, OpenID Connect, they're all out there, and you're really doing trade-offs of security versus usability. Now, obviously, in an API methodology, you do not want to give up security just for usability, because you have to protect your results, whether you be protecting privileged information from a particular user, or you just want to track that the developer that's building on top of your APIs it doesn't have a fire hose of your data coming through where they're just abusing your systems and you need to rate limit them. Auth is there to help with that. And when we're dealing with security, one of the mechanisms that basically, if you're dealing with systems like OAuth 2, your security method has to be changed a little bit. So some of the potential models that I'm sure a lot of you have worked with in the past and things that work really well within this type of architecture, things like proprietary solutions. This was so prevalent when I started in these auth systems, and I hate every single one of them. Because why build on a proprietary solution where users have to enter in all their information and have yet another account that's floating out there and more information? Why would you ever want a system like this? And I can understand you want to own the data that's coming through, but you can do all of that through the open constructs. Then, basic auth. Obviously, sending your username and password through is a very easy methodology. You send through an authorization header with your values coming through. Send that in every single request. It's a good way of authing the user. But then you're giving over control of your username and password to a developer that you can't revoke their entry in their database of your username and password. So it's not a very secure system. OAuth 1 was a very secure system, but a lot of developer pains. I've probably integrated 500 or more individual companies on top of an OAuth 1 and later OAuth 1OA implementation. And then when OpenID was around, the OpenID OAuth hybrid extensions. Now, all of those are very secure implementations, but the onus is on the developer to really build out the security mechanisms of encrypting all the data and sending it all through. And that should never be the choice. You should never give your developer or any of the developers building on top of your systems all the complexities of your security. Then that's why OAuth 2 came out. It was to simplify this effect. And then later, OpenID Connect, which was built on top of the OAuth 2 infrastructure, but with user management endpoints. Because essentially OAuth 2 was an authorization mechanism to give people give developers access to your credentials or basically your privileged data. OpenID Connect is more along the authentication or login type of structure. But the simplification led to a reduction in security on the overall developer side. But the way to handle that is to actually build it out in your server-side infrastructure. So the developers who are building out these OAuth 2 implementations need to have a proper security implementation in order to support that. They can't just acknowledge the issues that OAuth 2 might have as far as security and not put anything in place to support that. But the onus should never be on the developer to do that. So the last thing, and really the reasoning behind this entire API infrastructure and building out all of these changes into your APIs to support the developer community and everything that they're building out is because they are your lifeblood. And you essentially just want to build an API structure that offloads the complexity from them. Within the entire API infrastructures that we're talking about, every intricacy of trade-offs in RESTful-based structures, building on top of standards that are out there, that's everything that you're doing. And there are a lot of complexities that users are going to deal with. the auth models that we've just chatted about, legacy API support. Companies that have been around for a little bit have legacy APIs, have legacy systems. And supporting those methodologies and making it an efficient development environment can be quite tricky. And then working between versionings. You don't want to break your overall developer methodology, and the way to support that is through HATEOAS and those automation type effects. And, at the end of the day, reduction in latency is going to be a huge driver for a lot of your developers that are building on top of your systems, because that's going to give them a very seamless integration within your products. And as we're bringing everything together that we're talking about here, when you're building out an API architecture, you're just dealing with a bunch of trade-offs. You're never going to have a silver bullet that's going to hit everything that you want, that has the epitome of reliability, scalability, low developer latency, et cetera, et cetera. It does not exist. What you have is a series of trade-offs, and you have to pick the right ones. Move the slider towards the developers and make it easier for them to work with, because they're the ones that are going to build on top of your products. And again, you are not trying to build a perfect system. You're trying to build a perfect system for your developers and your community. That's simply put how it is. Now, the last thing I want to mention before I leave, PayPal as a overall company in its changing efforts, we are trying to build on top of these open constructs. And in doing so, we have a global hackathon series that's coming through. I say global because it's Europe-based and US-based. It's going to be expanding next year. But these type of methodologies in these particular cities, for those of you in the area, we're going to be working with a lot of API partners to build on top of these open constructs, to build in a for-good hackathon effort, and really try to improve the overall architecture of these systems. So if you're in the neighborhood, it's battlehack.org to sign up for any of these individual cities. If the for good aspects of improving your city don't wet your whistle, then we do have a $100,000 top prize for the winners, for the overall winner of the global hackathon. So again, thank you very much, everyone, for joining me. It's been a pleasure talking about these open concepts. I love talking about developer-oriented structures. So thank you very much. And I'm open for questions. Yes?
What are some of the best practices in sharing the API specs with other teams or other companies, as well as keeping them up to date with their behavior changes, behavior registry? What would you recommend?
All right, yeah, so the question was really basically sharing the API specifications between multiple groups and keeping them up to date, et cetera, et cetera. So basically, the way that we handle that type of methodology here is using an automation type of effect to the documentation. So you basically build out your API infrastructure on top of existing tool sets that build out your SDKs, that build out your API infrastructures, everything that you're building on top of. When you have that overall document that's built out, that you can build on top of, that means you can switch your API to multiple different languages to build out the SDKs. So creating a document like that is the proper way, and sharing that amongst individual groups. It basically takes down the API infrastructure to a schema level. Any other questions? Right there. Right. So basically, it was that the building on auth structures, right, on top of. Oh, right. Yeah, so building services like Clara on top of the existing RESTful infrastructure, because they are kind of at odds with each other on keeping state. Now, this is actually one of the biggest issues that I see with any RESTful-based services that are out there, and one of the things that I'm constantly fighting against as well, is that a RESTful specification in and of itself I treat as a guideline. I know that the RESTful specification itself specifies that it's an all or nothing type of effect. But in practical API development terminology, It's not. It never can be, because you have a series of trade-offs within your RESTful structures. You have to have what works for your environment. If you need to, it's the same way within our APIs. We don't have something that's completely RESTful because we maintain versioning numbers in our URIs, which is against the RESTful specification. Reasoning we do that is because we only are ever updating every several years, and within these updates we'll have incremental updates that don't change the versioning number, but we intend to support those long term. It all becomes the trade-off. So if you need to maintain states, there's some trade-offs that you're going to have to deal with in those cases. Any other questions? Yes. Yes. So basically, the automation type effects that I was referring to, and sorry, the question was around elaborating on top of what automation really means here. And the automation I'm referring to here is building out a more complex request response structure within the application developer environment to support potential next hops and support potential next steps. So, for instance, when you have this type of payload coming back, normally within your API structure, you would basically have a static-based system which calls out to these individual requests or these URIs. Now, the way that you technically do it, you only build in the first hop. You only build in, let's say, auth. And then all the stuff that comes back, you just build it into to be a smart system to actually call out to the next request as needed. So in auth, you don't have any sort of knowledge that you will ever capture until this comes back. So building in a type of automation effect will allow you to scale based on the scalability of the architecture. So as architecture changes on the API side, you'll change along with it. So you never have to update because this will always be supported. Yes?
Can you talk a little bit more about basic authentication? Because my company, we're in process of building REST API. We're using basic authentication with HATEOAS.
Yep.
Is that a good method, or is it something that when you talk about basic authentication, it's not exactly what security?
So your company's basically having the developers or the individuals pass through their username and password in order to authenticate?
Yes.
Okay. Yeah. So I still see a lot of companies that do a dual support. For instance, Reddit's API, for instance, supports both OAuth 2 as well as basic authentication. And the question there was, can I elaborate a little bit more on basic authentication, how to handle it otherwise? Now, our new APIs actually handle it quite in a nice, seamless way. They support OAuth 2, but not with the user involvement step. So you'll sign up for an application, and you're given an access key and secret, which can be seen like a username and password. The access key and secret can be revoked at any given time by the overall server implementation if you need to. Now, the way that we handle it is when, let's say, you're making a credit card payment, you're passing through an authorization header at the beginning, but passing through your consumer key and your consumer secret as the username and password in an authentication header. So it works in the same way as basic auth, but instead of returning results, it returns back an access token. So the access token gives you that skeleton key to access any further resources. So that's a way of migrating away from basic auth, which I just can't condone the development behind it or continued development behind it because of the potential security risks of giving outside developers access to people's usernames and passwords straight out without the ability for them to revoke it. So the proper way to do this is through an OAuth 2 bearer token methodology. So if you take a look at the PayPal documentation on developer.paypal.com, you'll see exactly what I mean based on the authorization headers. Yes?
Isn't that a bit of a straw man argument against basic auth? I mean, you're not required to use the user's email and password. You can just use a token in basic auth. Basic auth is just a mechanism for authentication, right? So I'm open to arguments that OAuth has better factors, but I don't think just saying, basic auth is bad because email and password.
No, so I should clarify here. So the And the question, the comment was basically around that it's basically a straw man argument against basic auth that you're passing through, in some instances, a username and password. And you're right. What I don't condone is the use of basic auth when passing through the username and password. The token-based system is exactly what PayPal does within their sending in that particular header with token-based implementation. So it's the exact same thing. It works like basic. Well, it is basic auth, sending in through, but it has those OAuth 2 methodologies around access tokens. So you're absolutely right. Basic auth, what I don't condone is basic auth utilized with username and password. Token methodologies are perfect because they can be revoked. They can be revoked by the end user. They can be revoked by the API implementer if the application gets unruly. So you're right. Yep. Any other questions? Oh, yes. Yep.
Are you aware of any emerging kind of standards for the response structure? Object properties, and then exactly even like the name of the list of links. I know there's no widely book about the REST API. They kind of presented some ideas there, but for me, they added a lot of stuff on top of this, and it started to kind of like soap. So I just wanted to I don't know if there's something that you're aware of. This is kind of an emerging standard.
So the question was around if there's basically an emerging standard on this type of effect coming back. When I've gone through basically the doctoral thesis for RESTful APIs, there is actually a good structure that's built in there on the data that you should be returning back and some of the data constructs that you're returning back. So yeah, there's standards. So there's basically information out there to give you kind of a standardization type of effect, but it's kind of Wild West right now. As you have noticed, APIs will return back any sort of data that they want. As long as you're returning back enough data for the developer to build out kind of this automated type of effect for next hop, it's fine. But no, I don't know of any particular standards based on this that have been enforced.
I see. Yeah, there's a standard. Obviously, trivial REST kind of a lot of discovery that just read everything and said, well, here's your REST API.
Yeah, and going back to the standards, I mean, OAuth is a prime example for this. Even though that there's standards in the industry, every single company almost breaks every single thing in there. I take in early OAuth 2 days, I think Facebook started integrating around draft revision 13, somewhere in the neighborhood. Before it was even completed, and they made some variations. So their implementation was varied based on other people's, and basically the spec was wide open enough for people to build out completely different implementations, and still maintaining kind of the spec. But there's nothing that I know of.
Okay.
All right, I think we're out of time. So thank you very much again, everyone, and I'll be over at the PayPal booth if you have questions.